Hey everybody, happy Tuesday, hope you're doing well. Alright, just a couple of things before we get started here. Close that down. Don't forget the syllabus quiz is coming up due. Got 2 more days on that one, so that'll be for next Thursday. Hey Blue, how you doing today? So make sure you get the syllabus quiz in. Again, this is should be free points there, and then a chance for you to think about when you're going to be spending time on this course, just kind of some planning ahead. Hey, Bendawi. Hope I'm saying your handle there right. How you folks doing? So, a couple things today. Oh, great. Yeah, thanks for coming along. So we've got Chapter 1 this week, and then we're going to have our first lab next Monday. So we got today and Thursday to do our Introduction to Python, GitHub, and PyCharm. We can do our actual first assignment then. We're going to do in lab come, that'll be 9/13. So remember, the labs are going to be behind because they're the stuff we talked about the week before. So we're going to do Tuesday, Thursday lecture, and we'll do lab on Monday for covering that content so you get a chance to practice it. And then we'll do the next chapter Tuesday, Thursday, and we'll do lab the following Monday. We'll just kind of keep that flow as we go. And then once we get to our variables and expressions, we can start looking at our first actual project. So we're going to have a couple projects throughout the semester. I hope everyone was able to get connected with the Zybook here. Again, it's fantastic. I think it's an excellent tool, much better than a traditional textbook. It works out to be a little bit cheaper than most textbooks as well, which I appreciate. The heads up or warning that you need here is what they have in Zybooks that they call labs or Zylabs. They're a bit particular, right? It's going to take some time and practice. So it's essentially like most textbooks might have like practice problems at the end of the chapter. In the Zybooks, it's a practice problem that you actually get to try and do, and you're actually going to get points for it. So 10% of your score is literally coming from reading the book and doing those exercises, those Zylabs there. So they're separate than the labs I'm going to assign on Mondays, where I'll be around to help. And it can actually be in person there, and it should be a lot of fun. I did note, I think in here, or maybe it was a note somewhere else, trying to remember. We talked about it last Thursday, but if you're not comfortable coming in person to labs, I'm happy to be flexible and work with you. Hey, Trumpet M4N? Trumpet Man? Is that Trumpet Man? How you doing? Yeah, good afternoon. So if you're not comfortable with the labs, coming in person, I get it. That's not a problem with me. We can be flexible there. But that is the chance that I have to be in person, kind of walk around and look over your shoulder and see what's going on as we're writing Python code. We do have other tools, and I'm happy to meet with you on Zoom or Discord or other screen sharing tools. Wow, the formatting in this looks terrible. What happened? Pretty sure it looked better and it wasn't all funky like that on my copy. I'm sorry, that just looks awful there. I'll double check that. It's just formatting, right? That doesn't matter. But the labs on Mondays are your chance to practice. We're going to do our official first GitHub PyCharm lab. So I showed you how to install all the tools. I showed you Python, whatever latest version, PyCharm latest version. We should be all set. GitHub, you just need an account. So every assignment that you have, every lab and every project that you have, I'll give you a link that will generate a GitHub repository for you. Throughout the class, I'll be putting my own code online in a GitHub repository. I think I put that link out there. Let me make sure I did that. Yeah, in our course repository. So all my code examples will go up to this course repository. No, I wanted new window. Yes, new window. Thank you. In a new window, so you'll be able to see all of the code that I write. It'll all go out here. After projects are due, I'll go over the solutions. I'll post the solutions online here as well. For labs, I will, depending on how they went, sometimes the first thing we'll do Tuesday is go over the lab. If people have questions, again, the goal with lab is that in that 1 hour, 45-minute block, you can get it done. Now, some people finish it sooner, some people it takes a little bit longer, and that's okay. But the goal is that that's the time we can sit and get it done. So labs are always going to be due in a week after they're assigned. So what I've seen happen before, and it's really unfortunate, is that people don't do it the day that's assigned, and then I talk about the lab on Tuesday, and then they're like, oh, okay, this is how you do it. And they essentially copy-paste my stuff and turn that in. Now, if you cite your source, you're going to get points, right? The labs are literally there for your practice. But what happens if you're not practicing and you're not actually doing the labs yourself, when it comes to the projects, you're probably going to fail real hard. And people just don't do well. So the labs, I'm happy to handhold you, show you every step of the way. This is what we do. This is what we do. This is what we do. But when it comes to the projects, I'm not going to ignore you if you need help, but like I'm not going to do it for you and show you how it's done like I will for the labs. So the labs are your chance to practice the things, and then the projects are your chance to show that, okay, the things that we've learned, the things that we practice in lab, I can apply to solve a new problem. I'm happy to get you unstuck, point you in the right direction, and all that sort of stuff. Make sure that it's working for you, but I'm not going to give you solutions. So just be aware. Totally up to you. Hey, thank you so much, Hector HSC. You've cheered some bits there. That's going towards the Student Scholarship Fund here at the University of Michigan Dearborn, where I'm both a student and a lecturer. That's pretty cool. So thank you so much for that. I have a list somewhere in my profile. I think you can just scroll down the page, or maybe it has to be there when I'm offline, I forget. And you can see that I've gotten paid out once by Twitch, and I'm a little bit ahead in donations, thankfully. They run their like Go Blue campaign every now and then, so I kick in every time they remind me here. So I'm a little ahead, which is nice. So, all right, so we're going to talk about Chapter 1. So I'm going to open up PyCharm, and I'm going to start a new project. So I'll typically do a PyCharm project for every chapter. Not usually one every Tuesday and every Thursday. Usually I'll combine them depending on how things go. So you'll always be able to go out and see it here. So we have our Hello World one from last time. Again, this was just a hello, this is Eric. Hi computer, happy Thursday. Hello human, nice to meet you. So just 4 lines here. It's a .py file, so our computer knows it's a Python file. It's not required, it's just a convention here. Makes life easier, and that's what PyCharm's going to do for us, so it makes life easy as well. I'm all about making life easy. Let's see, I think PyCharm was loading. Maybe it was loading. Uh-oh, rain is coming? Oh dear. That's all right, it's been really hot. We need some rain. Let's go PyCharm. Maybe it'll load here. That's not PyCharm. Oh, I clicked on the rain and that was the pop-up there. All right, and with PyCharm, you're welcome to have all the projects open at once, however you want to work. I'll typically try and close them. Just every time it opens, it wants to reopen all the projects, and that's kind of obnoxious. So you can have multiple windows open, but so when you go to start a new project, it's going to ask, do you want to start it in a new window or in this window? So I'm always going to choose this window to close my current project down. Just make life a little faster. All right, so we go File, New Project. And I'm making sure it's inside of my repository directory here. So it's in my folder, Documents, GitHub, name of my repository, and then / the name of the project here. I'll call this one Chapter 1. Right? And we are fine letting it create the main PY. It's fantastic, it makes the file for us. All this interpreter stuff is fine. The existing interpreter is fantastic for now. The virtual environments are great, but we're not really going to be importing anything until we get near the end of the semester, so we don't need to mess with any of those. And we're ready to create our project. Now this is the pop-up here. So you can do it in the new window, and you can have multiple PyCharms open if you want to be able to flip between your projects. I always just want to have one. So I'm just going to do it in this window here. And then over in the GitHub client, we open that up here and find our folder. We're going to see a bunch of new stuff. Sorry, this is my glucose meter here. This time my sugar's a little high. Oh, I forgot my coffee in the other room. I'm going to have to go get my coffee here in a second. Yes, I know my sugar's high. Let's take more insulin. Yes, take more insulin. This thing is super cool, by the way. This is like the coolest little tool I've ever had. Medical technology is amazing. All right, cool. So, oh, I gotta find the right repository here. So let me find my... I've got a bunch. You guys aren't gonna have as many. Don't worry about it. You'll have one for each lab and one for each project. So you'll get a stack of them at some point. But right, and now it says a bunch of new stuff, right? Anything that's a plus or in green is new. Anything that's orange is modified. Anything that's red is deleted. And this git ignore changed perfectly fine. Just let it go. And so that's inside of the .idea folder. .idea, that's for PyCharm. It keeps all of its files there so that we know it's a PyCharm project. If they change, they change. Not a big deal. What we really care about is our main.py. That's our Python file. And actually, I don't want any of this junk here, so I'm just going to go delete it all. And make sure I hit save. And now it should just say, hey, there's a new file here with nothing in it. So file's empty. Cool. So I'm going to give it a commit summary. Remember the commits here, that's the snapshot. That's this point in time of what was in this folder and what the contents were. So I'll say chapter 1 project started. Commits are free, and so I recommend you commit early and often. So once you have the commit, your local copy of the GitHub repository has it, but github.com, the central repository or origin repository, does not. So we're not in sync. So we need to push to make sure that we are synchronizing ourselves. All of my changes I'm going to push out to the central repository. Once we've done that, github.com has our code. It's really, really, really unlikely they'll lose it. Again, they make money by selling that service to people, so they're probably not going to lose that code. Okay, and then we can get started. We actually write some code in here. So I'm going to make it a little bit larger here. Let me enhance, enhance, enhance. So when it comes to Python code, there's a lot to it, and we're going to try and take it a little bit at a time. So the first thing we did, right, we said print, and then a set of parentheses. So anytime you have parentheses or braces or curly braces, they need to have a matching open and close. It's all the time. And then with print, we're going to give it single quotes or double quotes. So apostrophes or double quotes, either one. They're ever so slightly different. We'll get to it in a little while. And we put our message inside of here. So anything that's inside of quotes or apostrophes here is considered a string. So a string is just our technical term for a string of characters. It's a bunch of characters, or it's text. And this is just some text that we're going to put in here, and it's literally in our program. It's hard-coded in there, so a lot of times we'll also call it a literal. This is a string literal. So I'll say, Happy Tuesday. I'm going to save, and then, again, 5 different ways to hit run. You can click the run button up here. You can right-click and run. You can click the run button menu up here and run. Any of them are perfectly fine. I'm quite partial to the right-click run, because I usually have my hand by my mouse. If you like keyboard shortcuts, Control Shift F10 as well. That'll get you going. And then we'll see down below, we get our message. We see Happy Tuesday. That worked. And what's really cool, you can see, hey, this is the Python executable being called, and it's calling this Python file. So Python is not a compiled language. So Python is a scripting or interpreted language. So what happens every time you go to run a Python program, the Python executable for your operating system will go and read the Python file and execute it on the fly. It's pretty cool. So other languages like a C++ or C# or Java, your code here gets compiled into something else that's then run. In our case, nothing ever compiles. We just get the Python interpreter running it. And you can do all this by hand if you want. Which is a little bit tedious, but you can. So if you open up your command prompt or your PowerShell or terminal in Macland, I forget what it's called in Linux, you can do the same sort of things here. So what I'm going to do is, right now I'm in my Documents GitHub folder. Again, don't worry too much about it. We'll do some of this stuff come 2001. We actually spend a little bit of time and we work with the Python interpreter in the Unix system that we have access to at school, just to show you that, hey, Python runs in Unix land, and then we can say, yeah, we have people do stuff with multiple operating systems. Sure, but I just want to show you for fun. So I'm going to change my directory, because right now I'm in my Documents GitHub. I need to find my Documents GitHub CIS 1501. So CD for change directory, and I start typing CIS 1501, and then I'm a big fan of not typing things. So tab will autocomplete. So if there's something that matches, it says, oh, sure, do you want fall 2021? Now I'm in my GitHub CIS 1501 fall 2021 folder. Now again, I need to go to the chapter 1 folder. So CD CH for chapter, and then I tab for autocomplete, and it fills it in for me. So now I'm in chapter 1. If I ls or dir, whichever you prefer here, ls for list, that also works in Unix land. dir is our Windows side. I see I have a main.py file. All of this to find the main.py. Now we need to tell Python I want to run this one. So if I just type Python and hit tab, I get Python exe because it's in my path. It's not always in the path for you here. So in Windows land, you have this really cool thing called your environment variables, where you can set up a path that is searched automatically when you go to run programs. Depending on how you installed Python, if you installed it as administrator, there's an option to add it to your path. Great. If you didn't, no big deal. We need to go find it and tell it we want it to run. So c:\/ Python 37 python.exe. Great. I want to run the Python exe, and I want to have it run main.py. So I'm essentially doing this command, but because I'm in my directory already, main.py here, this is a relative path here. I don't need to give it this fully qualified path here to say this is everything, because that's a lot to type. And again, I'm lazy. If I'm in the directory and I just tell it run main, it knows how to run it. Okay, so I'm telling it, hey, Python, run this thing, and I get my Happy Tuesday out. Again, we're not going to do this now. When we get to the 2001 course, if you're continuing on, we'll do this on the Unix side of things, and we'll do it on the Windows side of things, and we'll compare. Turns out it works the exact same way, right? You have a Python executable that you tell to run your Python file, and it will go interpret your Python file and run it line by line by line by line. That's pretty handy here. All right, give me just a second. I gotta bring up my Zybooks on the other screen here, make sure I'm not missing any topics here. There we go. So yeah, this command line terminal Windows PowerShell thing, it's all fun. It's worth spending some time getting familiar with it eventually. Right out of the gates, it's a little overwhelming, and that's okay. You don't need to worry too much about it. But you'll want to be versed in how we can navigate around. And we can practice that more later. All right. Now, one of the things that I really love about programming is that it really is an art and a science. Yeah, PyCharm's it's a popular IDE. There's a lot of popular ones for Python, depending on exactly what you want to do with it. So Anaconda or Spider, those ones are pretty popular. There are, what are those workbooks? Jupyter workbooks are really popular as well. I'm a big fan of PyCharm because it gives me a really nice debugger. So when you're learning how to program, being able to debug your program is huge. And PyCharm is a really nice debugger as well, and it's going to work really well. It has some cool features for us when we get to more of the object-oriented side of Python. Now, this course is actually the same content, essentially, as our Computer Science 1 course that all of our CS majors take, but they learn it in C++. For the data science program, we said, well, we don't need to use C++. It's not a really popular language for data science. Let's teach them Python so that you have the Python know-how, but we still need that same content. It's still the basics of computer science, going through all the learning how to program and learning object-oriented principles. Not everything we do in Python is going to be fully object-oriented. You don't necessarily have to be object-oriented when you're writing Python code, but I think it's a great way of thinking about code and interacting with code, and a lot of the libraries out there are anyway, but it's not required. So programming is really an art and a science. So obviously the science side of things, you need to get it right. And there's a right way to do things, there's an efficient way to do things, there's all sorts of mathematical analysis you can do. You can get into that in the 300 levels course. Our data structures and algorithms analysis course is a lot of fun. But learning how to program and getting a computer to do the right thing is really an art. And this idea of breaking down a big problem into smaller and smaller and smaller and smaller problems. Because it turns out computers are actually really dumb. They only do what we tell them to do. And they do exactly what we tell them to do in the order in which we tell them to do it. So a lot of ways you can think of programming as like writing a recipe. So, you know, there's nothing really happening interesting right now, but we could say, hey, I want to have my hourly rate our hourly pay rate, I'm going to say is 9.5. So again, it doesn't have to look super familiar right now, but go with me here. So I'm going to say, I'm going to use this thing called hourly pay rate. Its value is 9.5. I'm going to say my hours worked this week. We'll say our 32 hours worked this week. What do you mean by book? Oh yeah, Python is definitely widely used. There's lots of machine learning libraries for Python. It's very popular for that. I don't remember what I was saying about book. I'm sorry, Bendawi. Oops, this week. So what we're doing here is we are creating these things called, oh yeah, Jupyter. Jupyter has a thing called notebooks, or yeah, Jupyter notebooks. It's just a way that the Jupyter program stores your code together. So you'll see that a lot of people use Jupyter notebooks for things. And it's a really nice online platform. But this one is nice for us just working locally, developing stuff. You got tons of options for it, but this one's free and has a great debugger. So I'm putting a name out here. This is called a variable name. So this value here, 9.5, is getting assigned to my variable hourly pay rate. So behind the scenes, Python is going to ask your operating system, say, hey, operating system, I need a place to store a numeric value. And your operating system will say, okay, sure, here's a location in my memory. So memory is RAM, that random access memory. It's really fast, but the problem is if you lose power, it'll go away. So it's temporary storage. So all of our programs, when they're running, store things in memory. So if you take a look at like your task manager, we can see my computer is using a bunch of programs and storing a bunch of things in memory right now. You can see your memory usage. See if this thing loads. So I see, hey, 80% of my memory is being used right now. That's my desktop window manager. I don't even know what that is. But PyCharm's using 711 megabytes of memory right now, right, doing some certain things. I've got so much of my CPU is in use. So the CPU is our processor. This is doing all of the work, doing all the computations that we need for our programs to run. Memory is where it stores information for short-term storage. So it's not writing anything out to disk, right? It's not saving any files. It's just while it's running, it's keeping this in memory so we can use it. And OBS, of course, is a little bit of a hog. But we can see it all being used there. So I tell Python tells the computer, the operating system, hey, please give me a place to store this value in memory. And operating system says, sure, go for it. Then we get hours worked this week. It's 32 hours. Again, it's sort of like following a recipe. I've got my steps, my step, and now I can do some arithmetic. I can say, okay, well, my pay this week will be equal to, now this is actually called the assignment operator. It takes anything on the right and assigns it to the thing on the left. So I'm going to say, hey, I need a new location to store something in memory. I'm going to call it pay this week, and we're going to take my hourly pay rate multiplied by my hours worked this week. And if you're not familiar with some of these shortcuts, if you just single click on something, it puts your cursor there. If you double click, it highlights everything. And then Control C for copy, Control V for paste. I'm a big fan of shortcuts. And then what I can do, I can just print your pay this week, colon. And now print is really cool. You can actually just comma separate the things you want to print. So I'm going to say your pay this week, colon, comma, pay this week. Now this is my recipe. This is my algorithm, is our technical term for that, of, all right, set a value, do some arithmetic, spit the results back out. And I'm going to right click run, and we should see whatever 32 times 9.5 is. Looks like 304. Now, I'm pretty sure Python's good at math, otherwise people wouldn't use it, but it never hurts to double check, right? Let's see what it should have been. Let's ask the Windows calculator. So I want 32 times 9.5, 304. All right. So if we work 32 hours and we get paid $9.50 an hour, we got paid not even enough to pay for 1 credit hour. That's rough. And multiply that by 15 weeks, we're still in the hole. Well, crap. I mean, maybe we could work more, right? The text here is a print statement. For websites, web programming is a totally different thing. Yep. I don't think Python's very popular for web programming. I think you can do it. I've never done it, though. There's lots of other good languages for web programming. Right, so this is just our step by step by step. This is what we're doing here. Right, now, what's can happen, though, is if I didn't type a multiplication, if I did a plus here, and I wanted to add these two together, the computer's more than happy to do this for me, but I'm not going to get the right result because I want to do the wrong thing, right? 32 plus 9.5 is probably not how you calculate your pay for the week, right? So this is an error in my code, a logical error or a logical bug. The bug in the code because it's doing something wrong. It's doing what I told it to do, but I told it to do the wrong thing, so that's my mistake. All right? And then you can see we can do all sorts of arithmetic in the computer, but doing this step by step by step by step, that's the hard part of programming. When you're given a problem, like, hey, calculate someone's pay, we might be able to just do it on paper or even in our head, depending on how good you are at mental math, but getting it down step by step by step by step, simple enough so that the computer can do it, is the art. And there's tons of different ways of doing it, different ways of naming things. Whatever this name is over here, again, I mentioned this is a variable name. Programmers get to pick the variable names. Python could care less. If this was A, Python would be happy. As long as everywhere I want to reference it, that's A. This could be B, and this could be C. Please, 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 please don't ever do this, though, because I have no idea what A, B, and C even mean here, right? Who knows? It's garbage. So I'm just going to undo a bunch here, right? Undo all those renames. But Python doesn't care. The people who care are programmers. The reason why we write code is so that we can understand it, right? The code is for people. It just happens to be that Python will read it for us. Right? We need to write it in a certain way so that Python can do it for us. But, you know, the code is for people. We need to be able to know what this means. So hourly, pay rate, there's nothing wrong with these long variable names. A common Python convention is using these underscore characters. That's the shift dash right next to 0. Some people call this snake casing. But I don't know. Sure. Other languages have other conventions. It really doesn't matter one way or the other. Python doesn't care as long as we use this right name. So the problem is, if you typo it, though, if you say, hey, hour worked this week, it's going to be all upset, and you're going to get this nice red line. It's going to say, unresolved reference, hour worked this week. An unresolved reference means Python doesn't know what you're talking about. It doesn't know what an hour worked this week is. It doesn't match with anything up above, so we need to make sure we fix that typo. It's hours worked this week. Okay? So we can figure that out. So these are our statements, right, in Python. This is an expression, right? We're generating a value. We're asking Python to do something. We're using this assignment operator. So the assignment operator takes anything on the right and stores it, assigns it to the thing on the left. In Python, you can also include something called a comment. So if you notice when we first started off our program, we had a bunch of boilerplate stuff in here. They have the pound sign. Now, I refuse to call this a hashtag because I'm an old grumpy man, and it's been a pound sign forever, forever, and forever, and forever. It's not a hashtag, it's a pound sign, right? So you can, anything you want to put after here, this is a comment, and is ignored by the Python interpreter. So when the Python interpreter goes to run our code, when you say Python exe, run this program here, if it sees a comment, anything that comes after it is just ignored. It means nothing to it. It's going to completely skip it. Comments are put in so that you can add additional notes. Now, a funny thing here, and I'm definitely different from many of my colleagues here at the college, in that I tend to think if you need comments, you've done something wrong. And that's a big industry sentiment. The goal here, and I know it's a little bit rainbows and unicorn, like La La Land, is that if you have the right names of your variables, you don't need a comment that says, hey, this is going to calculate the hourly pay rate. Right? Because you can see, oh, hourly pay rate, hours worked this week, here's my pay this week. The idea is that code should be self-documenting. And back when I was an undergrad, taking my very first programming course. I wrote my project out, and I got everything working. It did all the things it was supposed to do, and I got a point taken off because I didn't include a comment describing something that, honestly, I was supposed to, but I got a point off, so I didn't get a perfect score on it, even though it did all the right things. And I was so upset and frustrated that I swore to myself at that point in time, this was back in, this would have been 2005, that if I ever had a chance to teach programming, that I would never take points off for people not including comments. And to this date, I have kept to that. So I'm not going to ask you to include comments for anything. Okay. Again, that might be a little extreme. You know, there's certainly cases where comments are helpful and useful and wonderful and all that, but I'm not going to ask you for them. My focus is helping you learn how to code. Adding comments around your code, I'm sure you can figure out. You folks are smart people, right? If you can learn to make the code do the right thing, I trust you can figure out how to add a comment if someone wants you to add a comment. And every organization is different. Some organizations have standards around you have to comment certain things in certain ways, and sure, you know, that's fine. Typically, my rule of thumb tends to be whoever's writing your paycheck, if they have some sort of convention where you should name your things a certain way or you should add comments for certain things, just smile and nod, right? Just, okay, sure. Especially as a new hire, you're not a senior engineer, you don't have a decade of experience. Don't go in and be like, oh no, lecturer Charnesky said never to put comments in. You're just going to look stupid, and you're going to make me look stupid too. Let's just be honest, okay? So just smile and nod. It's not going to hurt anything. All right, so we're able to have Python do some arithmetic. Now, the problem with this is it's really, really boring, because if I want to change your hourly pay rate, I have to go into my program, change the number, and rerun it. Or change the hours that you work, go into my program, and rerun it. So it's not a very useful program at this point. So what we can do instead is we can make the program interactive, in that the program can ask the user to type something in, and they can type in a number, and we can use that value. So we can use whatever value has been typed in to do our arithmetic, and it's going to work a lot nicer for us. Those are printing. Yeah, we did printing already. Great, 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 great. Sorry, there it goes. So if you want to get input from somebody, we have a command for that. Okay, so the command is input. And then, now the text doesn't always do this. So our textbook likes to say print, enter your hourly pay rate, and then they have an input that's blank. Sure, there's nothing wrong with that. What I'm going to do instead is I'm going to take this message and I'm going to stick it inside the input, because that makes life easier. So your input can say, here's the prompt. It will output something, and it will wait for them to type something in. Now, the one downside with using input is that because it doesn't know what kind of value to expect, everything that comes in through input is going to be a string, a bunch of characters. So we're going to get the characters of your hourly pay rate, not the numeric value. Okay? So we need a way to change that. We need to say, oh, instead of this being a numeric value, I want this to be, and now we have this new thing in Python called a float. So a float is a floating point number. It's a number with a decimal place. Right? So floats are numeric values with decimal places. Now, it doesn't mean it has to have a decimal place. So my pay rate could be $10 an hour even, but if I wanted an integer value and I told them my pay rate was $10.50 an hour, an integer value is not going to work for that. So integers or ints are numeric whole numbers, right? Integers, right? Int for integer. So we have different types of values here. So I'm going to do both of these as floats, because you might work an odd number of hours and your pay rate might not be a nice even number here. So I'm just going to copy paste this here and enter your hours worked this week. So we're going to say, okay, give me some input for your hourly pay rate. Great, whatever that input is, turn it into a floating point number, because it's probably going to have a decimal place. Give me how many hours you worked this week. Turn it into a floating point number, because maybe it's a partial number of hours, because if you work a quarter of an hour, you should get paid for that quarter of an hour. Right? Otherwise, that's wage theft. That's not cool. Okay, so now when we run our program here, down in this output section here, we're going to get our prompts. We're going to get enter your hourly pay rate. And you notice now I'm just sitting here with the cursor, so I need to type something in. Okay, so let's do 9.5. I hit enter. The enter key is telling Python, okay, great, here's the input, let's go. All right, hours worked this week, let's do 32 hours. Oh, I still have my typo here. I forgot to make that a multiplication sign. Let me fix that. Run it one more time, make sure it does the arithmetic properly. Let me zoom that in here. So hourly pay rate, and I want to change the prompt a little bit. We can put like a colon and a space, make that look a little prettier here. All right, I'm going to hit stop over here, and I'm going to run it again. All right, we'll zoom in. All right, enter your hourly pay rate, 9.5. Hours worked, 32. All right, your pay this week, 304. Fantastic. Now let's run it again. Now what happens is my program can be used for anybody. They just need to enter their values. So I don't need to go and change my program and change the literal values that I put in here. Right, so if my pay rate was $15 an hour and I worked 32 hours, I'm going to get 480. Look at that, that almost pays for 1 credit of courses, right? So if you work 32 hours a week at $15 an hour, you can pay for 1 credit of classes, almost. Is that right? Are we just a little bit above that? I'd have to look again. You folks with me so far? So we're able to use this input prompt here to get some input from whoever's running our program. So every time I run the program, it waits for me to type something in. Now the problem is, if I go run this again, when it asks for my pay rate, if I type like 15 in text here, it's going to crash. So this big red message here, this is an error, and this is called a stack trace. Don't worry too much about it. We'll see this is what went wrong here. And it's actually pretty nice here. It's telling us a value error. Could not convert string to float. The string here was 15. Remember, anything that comes from input is just a string of characters, because the computer doesn't know what we're supposed to type in. We're telling it, hey, turn it into a float. And the computer's puking here saying, nope, I can't turn the text 15 into a float value. It's not that smart. And then the next thing we see here is the actual line of code, and came from line 5 in our main.py file. So as we get bigger and bigger and bigger programs, you can see this is really useful. You'll be able to find out exactly where it errored here. So at line 5 here, we can see, oh, hey, this just crashed. This was no good. All right. Now the other cool thing, someone had asked about different development environments or different tools that we use for writing Python. One of the reasons I'm fond of PyCharm is the debugger. So I come over to my line numbers, and there's the big old empty space next to my line numbers here. If you just click, it adds a big red dot here. That's called a breakpoint. So a breakpoint means that when your program is running, it's going to pause right at that line so you can actually see what's happening behind the scenes. So now I'm going to right-click. I don't want to hit run. I'm going to right-click and hit debug. So the idea with debugging is that you can see behind the scenes and walk through step by step by step by step, see what your program's doing. It takes a little longer to start. Don't worry too much about it. We'll get there. All right, while I wait for that, I'm going to grab my coffee real fast. It's just in the other room here. I'll be right back. All right, sorry, I'm back. I never realized how nice it was while I'm sitting here talking for a long time to be able to actually drink. So when I'm in person in classes and have a mask on, I can't drink in class. It's actually a little sad. All right. So now it's sitting here waiting for me to enter something. So I can type in my value, enter your hourly pay rate. Again, let's do, what do we say, 9.5. I hit enter. Okay, cool. Now it's waiting for me to do the next one here. I can flip from here over to the Debugger tab. Is it actually connected? It's not connected. What's it doing here? Uh-oh. It didn't actually connect right. Nope. That didn't work. Let me try one more time. It should have paused. It did not. I think my PyCharm's confused. Come on, Debugger. Nope. Okay, that didn't work. Why did it not work? Hello, friends. Let me try more breakpoints. Nothing. All right. I might just need to update PyCharm. It's a little stale right now, but it should have worked. I'll make sure it works on Thursday. But ideally, we can see what's happening behind the scenes. But it's not cooperating right now. I'm sorry. It's okay. Other things you'll see, like in the textbook, when we use those print statements, if you don't want it to go down a line, which what happens automatically, you can put a different ending character and say, hey, I want you to end with, instead of a new line character, I want you to end with nothing. If you want to do that, totally up to you. Not a big deal. I typically don't do that because, again, it's more work, right? I'd rather just have a single print command instead of changing the end here. So other things you might get, other errors, are syntax errors, where if we don't put the right thing, so if I don't have a comma here, and I hover over, I get this little red line that says, hey, a semicolon or parenthesis was expected. Not actually going to fix it. So the hover suggestions aren't always perfect, but it's saying it expected to end this parenthesis because it doesn't know what to do with these two things here. So that's, I need my comma here. Right? You might get syntax errors. So when you're working on writing your code, a really good practice is to do it little bit by little bit by little bit. So write a little bit of code and run it, make sure it works. Write a little bit of code and run it, make sure it works. Instead of write all of your code and then hit run, and if it doesn't do what you expect it to do, you're going to be a little bit confused on where it's not working out quite right for you. Yeah, other errors, great. Some common errors. Logic errors where we screw it up, we do the wrong thing. Oh yeah, the reason why we call it a bug, the fun little history here in Wikipedia, there actually was a moth on somewhere. We used to have to write our code certain ways. Hey, what's up? Why? Aren't you doing it on your laptop?
We don't have the number.
Oh, do you need the number? All right. Now, yeah. So I gotta get the number here real quick for my daughter. She's gotta do her Zoom lesson.
Hello.
Hi, Journey.
Mhm.
Wait. Okay. You see it? All right. Now in Python, the white space matters. So the white space is like new lines are fine. It's going to ignore all new lines, but tabs are important. So if we try and put some code in here, and I'll do another print test. Notice it doesn't even light up purple. Oh, it is. Okay, it does light up purple now, but now we get a nice red error here. This little red line. An unexpected indent. So everything has to be left aligned for it to work. Even a single space in there is going to upset it. So it needs to be lined up properly along that left side for that to work right. You know, white space, spaces here, no big deal. It's fine with those. But the alignment is really important, and as we get there later on, we'll see things have to be indented certain ways. Again, we're not there yet, so that's okay. Don't worry too much about it. But I can run this now. I don't know why my debugger wasn't working. Maybe I just need a reboot. Yeah, our pay rate, so let's say 15, 32 bucks. All right, and then we see our test. Great. You can see all that. The little ASCII art practice is fun. Another cool thing you get with Python when you install it is this thing called idle. So idle is a quick little, it's called a REPL environment. What does REPL even mean? I have to Google that one again real quick. REPL definition. Oh, I can't even spell the word definition. Maybe it figures it out for me. Read, evaluate, print, loop. Is this idea that we can just start typing into this idle environment, and it'll read the code, evaluate it, it'll print, and it'll loop back for us. You all set? Thanks, Jubilee. You want to say hi?
Hello.
That's Jubilee. All right, pull the door, please. Thanks. Oh, goodness. What a day. Right, so when that finally opens up, you get this little 3-arrow prompt, and right in here you can start writing Python code, like print test, and I see my output here. I can say print 10 times 5, and I'm going to get the result of 10 times 5. Right, so this is not in quotes, so it's going to do the arithmetic here, 10 times 5. The REPL environment is pretty cool. Just if you want to do something quick, you don't need to fire up PyCharm, you can just open up a quick idle shell and start writing Python there. It's kind of fun. One thing to note, the order of operations does apply, right? And I've had many people get confused by this, which makes me really sad for our primary education and secondary education. Like, I don't know why that doesn't make a lot of sense for people. But if you do 5 plus 10 times 50 minus 50, the order of operations is going to apply. So you don't do 5 plus 10 first. You do your multiplication and division first. And now, do remember, okay, so if we do it this way, 5 divided by 10, let's do 20, divided by 10 times 50 minus 50. We'll do some addition in here as well, right? How about we do 10 plus? So I've had people be confused before, which is just really sad. And they say, well, when you say PEMDAS, or please excuse my dear Aunt Sally, you say parentheses, exponents, multiplication, division, addition, subtraction, that you should do your multiplication first because you say it first. So we're just doing a really bad job of teaching that, because multiplication and division have the same order of precedence. They have the same level of precedence. So that what you do is you evaluate them from left to right. So you do the division first, then you do the multiplication, because the division is on the left. Same with addition and subtraction. Just because you say addition first doesn't mean you always do all the plus signs first. Right? If there's subtraction to be done on the left, you do the subtraction on the left. So what we're going to get here, we're going to get 20 divided by 10, should be 2, times 50, should be 100, 10 plus 100 minus 50. Right? We should get out 60. Right? So order of operations applies. All those stupid things, I guess no young folks use Facebook anymore because it's not cool, and that's why all these old people share these things and they get really confused. They're like, no, nobody can figure this out. It's driving me crazy. So order of operations applies. Yep, cool. Old-fashioned programs. The computer history is really interesting. What it all boils down to is numbers are stored, or everything actually is stored in binary on our computer. And binary means it's zeros and ones, because it's the only thing our computer can store. It can store in that little spot, in that little location, it can store a charge or no charge. Right? So that's how we know, and we just add all those together to start making whatever we want to store, we start storing that information in these chunks of zeros and ones binary code. If you're continuing on, you might take the 310 course, which is Computer Organization and Architecture, or something like that. You should probably know the actual name of the course, but you'll do all sorts of fun things, learn about binary there as well. But one of the fun things with binary is that it's base 2, because it's either on or off. So the only possible values you have for things are zeros and ones. So let's see if this will load for me here. Come on. Whiteboard, you're not a difficult program. Okay, thanks, Whiteboard. Change some settings. Sure. I think my computer needs a reboot. All right, I got my fan on higher here to help cool off a little bit more. Let me clear this. All right, so with our regular number system, if I give you a number like 4321, you know this is 4,321 because this is the ones place, this is the tens place, this is the hundreds place, this is the thousands place, right? Now, we don't often write it like this, but what that means is because this is base 10, this is 10 to the 0, 10 to the 1, 10 to the 2, 10 to the 3, right? 4, 3, 2, 1. So 10 to the 0 is 1, 10 to the 1 is 10, 10 to the 2 is 100, 10 to the 3 is 1,000, right? That's how we get our place values for these numbers here. Sorry, that's like kind of like that. So in binary, we get 2s. It's base 2. So we get 2 to the 0, 2 to the 1, 2 to the 2, 2 to the 3, 2 to the 4, 2 to the 5, 2 to the 6, 2 to the 7. So that is 1, 2, 4, 8, 16, 32, 64, 128. So what we typically do is we will take 8 bits. So bit is just a single 0 or 1, and we put it together to be a byte. So a byte is 8 bits. So 0, 0, 0, 0, 0, 0, 0, 0, right? And if they're all off, represents the value 0. 0, 0, 0, 0, 0, 0, 0, 1 is the value 1, because we have 2 to the 0 is on, so we get a value of 2 to the 0, which is 1. And 0, 0, 0, 0, 0, 0, 1, 0 is 2. So this is the 2 to the 1's place, right? Has a value, so we get a 2 there. And then 0, 0, 0, 0, 0, 0, 1, 1 is 3. So the 2 to the 0 has a value, and the 2 to the 1 has a value. So we add up 2 plus 1 is 3. And on and on and on. So then we get 1, 0, 0, 1, 0, 1, 1, 1, 0, 1, 1, 1. Right? It's 4, 5, 6, and 7. On and on and on and on and on. So eventually you work your way up, and you get a bunch more numbers here. Doing the math is hard, but it's really cool. The Windows calculator has a cool mode. That mode is called Programmer Mode. In Programmer Mode, we can go right to binary and work with bits. So instead of Standard Mode, if we go to Programmer, I can change from decimal, which is my base 10 system, to binary. And then I can even, from here now, I can go to this bit toggling keypad. It's super cool. So this is showing me, so this is the first byte, here's the second byte, the third byte, the fourth byte. So I can just turn these bits on and off, and I'll see, oh, that number in decimal is 128. Right? That's 2 to the 7th. 2 to the 1, 2 to the 2, 2 to the 3, I'm sorry, 2 to the 0, 2 to the 1, 2 to the 2, 2 to the 3, 2 to the 4, 2 to the 5, 2 to the 6, 2 to the 7. On and on and on. Now, typically with integer values, they are done with 4 bytes. So we take 4 bytes altogether. So 2 to the 31st is 2,147,483,483 183,648. So we can store numbers up to that amount using 4 bytes. Right, so 32 bits to store my integer values up to 2 some odd billion and a little bit. And now the other thing, because numbers can be positive or negative, typically we'll reserve one of those bits to be the flag for this is a positive or negative number. So really, what we're going to do is we're going to save this first bit for positive or negative, and then the other 31 are going to be this number. So, and I don't know how far you've gotten in math class, but you might have seen with this particular series, all of the previous numbers, if you sum them together, are 1 minus the next. I don't know if that makes any sense. But if we look at all of our place values here, like this place value is 8. It's the sum of the previous 3 is 1 less than that. So I get to 7, and the next value is 8. Then if I turn all of those ones on, I get 15. The next value here is 16. Right, so on and on. So we turn on all the bits except for that first one here. Click, 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 click. We're going to get 1 less than that number we just saw. I'm going to go toggle all the bits because it's fun to click them. So 2,147,483,647 is the largest integer value we can store in Python. Now Python can store bigger numbers. There's other things it can use to store those, but just that's a typical common max value here. And that's all binary. So again, we're not going to worry too much about it. Just know that binary exists. That's how we store things. It's pretty cool. We'll get to it more later. More about computers, great. Python history, sure. Get our salary calculator. Fantastic. So we are actually almost done with chapter 1. You folks have done great. So we can do a little more practice with it on Thursday. And then definitely spend some time, read about some of the history stuff. It's interesting to know. And then after Thursday, I'll post a quiz on chapter 1 that you folks can take. All right, the quiz will be open all week long till the next Thursday, 11:59 p.m. It's open book, open notes. So again, it's your incentive to go read the book. Not only are you getting points for doing the book, but you can go actually read the things for the quizzes, that sort of thing. Please don't memorize anything out of the book. It's not worth your brain power to memorize the stuff. Just know where it is. Okay? So I think we're good. Any other questions before we call it a day? If not, I'll see you on Thursday, same time, same place. And then the following Monday, we'll have lab in person in the HPEC building, room 1190. We meet at 2 o'clock. I plan to come a little early to make sure you can go through all the screening process, have your Responsive Blue app thing ready to go. And if, again, you're not up for coming in person, that's okay. Just let me know you want to be remote. I can be on Discord or Zoom sessions or something during that lab time, and we can hop on as well. But that's the time I've got dedicated to hang out with you folks and help troubleshoot things. All right, I think that's it. Awesome. So why don't I put this in ending mode? So it usually runs a little better for me. And we'll send a raid off somewhere else for fun. Part of the fun of Twitch. We'll go raid some fun friends. Someone else in the Knowledge Fellowship, probably. It's a bunch of streamers who just like to share interesting information. Ooh, we can raid Obother. He's a lot of fun. He does a lot of circuit stuff, too. He's doing Arduino right now. So go check that out. Say hi. And you folks take care. Yep, have a good day. Take care, Trumpet Man. See everybody around.